Let us solve the next question. I am marking question number 8. Here it is given a square PQRS of 2 meter side is subjected to forces 10 kilonewton, 20 kilonewton and 30 kilonewton along AB, CB and BD respectively, full stop. Find the magnitude, direction and position of resultant with respect to point A. So here again I will write the data first. We are into question number 8. Here we have square ABCD whose sides are of 2 meter given. Next, square PQRS of side, okay, here it is given as PQRS, so instead of ABCD I would be writing it as PQRS of 2 meter side is subjected to forces. Okay, so what we'll do here, see, instead of PQRS I will just write it as ABCD. Okay, a square ABCD of 2 meter side is subjected to forces 10, 20 and 30 kilonewton along AB. Means along AB we have 10 kilonewton. Next, along CB, or you can say along BC, it is 20 kilonewton. Then along BD it is 30 kilonewton. So for BD we have to connect these points B and D to get the diagonal. Along this diagonal the force is 30 kilonewton. And since this diagonal is connecting B and D, the angle is 90, so this angle will be 45 degree. Here we have to calculate magnitude of resultant, its direction and position with respect to point A. That is, we have to even calculate theta here. So now I would be writing the solution for this problem. In this case, here we have to see that all the forces are horizontal or vertical. If we see along AB, 10 kilonewton is vertical, along BC 20 kilonewton is horizontal. Next, only BD, this force is 30 kilonewton, so we will be resolving this force. If I resolve, I can write it here. Horizontal component will be 30 cos 45, vertical component 30 sin 45. So therefore now I can easily say that since sum of all horizontal forces is given by summation fx, in which all rightward forces to be taken as positive, all leftward forces to be taken as negative. Hence summation fx will be, here I have 20 kilonewton as horizontal towards right, so positive, 30 cos 45 towards right, so positive. Only these two horizontal forces are there. So if I calculate this, I will be getting my summation fx value. In this case it is minus 11.21 kilonewton. Negative means it is acting towards left. Now in the same manner we would be calculating the sum of all vertical forces. Since the sum of all vertical forces are given by summation Fy is equal to rightward forces to be taken as positive and downward forces, you can say upward forces positive, downward forces negative. Therefore summation of Fy will be equal to If I look into this diagram, 10 kilonewton is downward, 30 sine 45 is upward, hence I will be getting my summation of Fy answer as 1.21 kilonewton. Since it is positive, therefore acting upward. After getting the sum of all horizontal forces, the sum of all vertical forces, now we can find resultant. Resultant is given by capital R is equal to root of summation fx square plus summation fy square. Summation fx minus 11.21 whole square plus summation fy 1.21 whole square. Therefore, I will get my answer of resultant as 11.28 kilonewton. This will be my first answer, the value of resultant. Now we will be locating this resultant by using the formula of theta. I'll say that since theta is equal to tan inverse summation fy upon summation fx, therefore theta is equal to tan inverse of summation fy. My answer is 1.21, summation fx 11.21. If I calculate the whole value, I will get my theta as 6.16 degree with respect to horizontal. After getting the value, we can say that even we can locate the resultant with respect to point A by taking the moments of all forces at point A. So what I will do here, I will write down now by Varignon's theorem of moments, summation of moments about A is equal to the moment of resultant, where clockwise moment is to be taken as positive and anti-clockwise moment should be taken as negative. So therefore, if I see in the diagram, since 10 kilonewton is acting through point A, there is no perpendicular distance between 10 kilonewton and point A, so its moment will be 0. So here I will write down simply 10 into 0. After that, if I see this 20 kilonewton force, I take the moment, it will be in anti-clockwise direction, so minus 20 into 2. Then I have two components here, two components of forces now. Out of those forces, 30 sine 45 will be the force passing through point A, so its moment would be 0. I am left with only 30 cos 45, which would be acting in anti-clockwise direction, so minus 30 cos 45 into 2. So now we have all the forces here, and that is equal to the moment of resultant. My answer was, it is 11.28 kilonewton, and since the answer is positive, it is 11.2128 kilonewton, so I can simply write it as 11.28 into x. X is the distance which we have to calculate. So after solving this entire term, here we would be having, in this case, here I have 10 into 0 minus 40. This value would be around, you can say this is 60 cos 45, and that is equal to 11.28 into x. So if I calculate the whole value, my x value comes out to be, it is okay, its complete answer is 0.21 meter with respect to point A. This is the value of x. Now what I can do here, Once we know the value of x, we can even locate the resultant. I will draw this square again. Here I have point A. I will replace all the forces just by one single force. That force would be called as resultant, and its distance with respect to point A, the distance is, we have just calculated, it is 0.21 meter. Next, after this, we were getting summation fx as negative and summation fy as positive. So it means that if I draw one horizontal line by extending this vertical line, now that indicates that my resultant will be, it will be in this quadrant, which is in the second quadrant, and it would be at a distance of 0.21 meter with respect to point A that we have already calculated. So my resultant, if I can locate this, it would be something like this. Capital R is equal to, the value is 11.28 kilonewton. The distance of resultant with respect to point A, it is 0.21 meter, and the inclination of resultant is, we have found out, that was 6.16 degree with respect to horizontal. So here I have inclination, which is theta is equal to 6.16 degree with respect to horizontal. So in this case, we have found the single force that is the resultant, which will give you the same effect as the other three forces, and that resultant is inclined at 6.16 degree with horizontal, located at 0.21 meter from point A. And with this, we complete the problem.